In this video, we'll be looking at some various theorems that help us set up proportions to find missing sides on triangles. So the first one is called the side splitter theorem. And it says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So that's a lot of words to mean that we can set up some proportions if the two bases of our triangles are parallel to each other. So here we have our two parallel bases. So then we can set up our proportions based on what the picture looks like. So if we have A and B that we're given, then we can set that equal to C over D. So let me erase that. And then if we are given A and E, so if we're given the top and the length of the whole side, we can set that equal to the top and the length of the whole side on the other side of our triangle. So it'll be C over F. And then the last one, if we're given B and E, then that is the bottom and the whole side. And so we can set that equal to D over F because that's the bottom and the whole side. So we're going to look at some examples and see how this works itself out. So on the first one, we have two parallel bases. So that means we can set up our proportion based on how the picture looks. So for this one, we'll be able to do 33 over X equals 27 over 18. And then we'll cross multiply that. So we'll do 33 times 18 and then divide by 27. And we get that our X is 22. On the next one, we're given the bottom part of our triangle and then the whole length of the side of the big triangle. So what we can do, since on the other side we only know the top and the bottom of the triangle, so we know the top part and the bottom part, we could set that equal to the top part and bottom part of this triangle, except that we don't know this top part. Except the whole thing is 14 and the bottom is 4, so that makes the top part 10. So then we can do 10 over 4 equals X over 6, and then cross multiply. So we'll do 10 times 6 and then divide by 4, and we get that our X equals 15. On the next one, it's flipped on its side, but that's okay. We still have our two bases that are parallel to each other. And on this one, we know the top of the triangle and the whole thing, so X and 20. And then on the other side, we know the top of the triangle and the whole thing. We could add those two together, would be 16. So we could say X over 20 equals 12 over 16, and then cross multiply. So 20 times 12 and then divide by 16 would give us X equals 15. And then the last one is different because it doesn't give us sides along this side of our triangle. So that same theorem that we were just using isn't going to work because we're not given the same type of information. So what we're going to have to do is look at each triangle separately. So the small triangle, our side lengths would be 6 and X. So we'll put 6 and X together. But then for the big triangle, the side length of the big triangle isn't 4. The side length of the big triangle is 10. We have to add both of those parts together. So we'll put 10 and 20 together. And then we'll be able to cross multiply that. So 6 times 20 and then divide by 10 would give us that X equals 12. So it's really important that you remember this. Make sure that whenever you have this base given of the smaller triangle, you can't just do 6 and X and 4 and 20 together. It has to be the whole sides of those triangles like we set up before. Next we have, it's called a corollary, which means that it correlates or relates to the one that we were just looking at. So when we have three parallel lines, it looks kind of like a ladder, and it'll tell us basically what our proportion should look like again, just like the last one. So if we have our three parallel lines, A, B, and C, we can set up our proportion just the way the picture looks. We should be able to do X over Y equals W over Z. So then we'll look at a couple of examples. So on the first one we have our three parallel lines. So we can do 10 over 15 equals X over 14, or 15 over 10, sorry, equals X over 14, and then cross multiply. So we'll do 15 times 14 and divide by 10. We get that our X equals 21. And then we'll look at the next one, and it says, given that AB is 50, So we know that our whole distance from here to B is 50. We want to find x. So on the other side, we can add all of these together and see that our whole side over there is 30. So if we're looking for x and 8 go together, and then the whole sides 30 and 50 go together. And so we could do 8 would go with 30 because they're both on the left side, and x would go with 50 because they're both on the right side. And then we'll cross multiply 8 times 50 and divide by 30, and we get that our x equals 13.3 repeating. So we don't want to leave it as a decimal though, we'll just write it as a fraction, 40/3. And on this one, whenever we have an angle bisector, this one also will show us kind of what our proportions look like. What we can say is, I'm going to label each of my sides as x, y, z, and w. When I have an angle bisector, I can take the two side lengths from one triangle, x and y, and make them a ratio. So x over y will equal w over z. And then we should be able to go from there to find whichever variable we're missing. So for this one, we know that this part is 18 and the whole thing is 42. So in order to set up our proportion, it'll be x over something equals 27/18. So to find that missing part, we're going to do 42 and subtract 18, because that means that we'll have 42 minus 18 will be what's left for there, so it'll be 24. So our proportion would be x over 24 equals 27/18. And then we'll cross multiply, so 24 times 27 and divide by 18 gives us that our x equals 36. The next one's a little bit trickier because we have a little bit more going on here. So we're going to do 6x and 5x will go together, and 10x minus 4 and 7x will go together. So for our first proportion, or for our first ratio, we can do 6x and 5x will go together. And then on the other one, we'll have 10x minus 4 and 7x will go together. Now to make things a little bit easier, we want to simplify this if we can. And so what we can do is we can take the two x's in the fraction on the left and we can cancel them out. However, you cannot cancel out the x with the 10 and the x with the 7 because we have this minus 4 here. So we're not allowed to cancel those out in the same way because it's not just an x divided by an x. So once we cross those out, we cross multiply. And so when we do our first cross this way, we have 50x minus 20 equals our other cross going this way, which would be 42x. So then we subtract 50x from both sides, so negative 20 equals negative 8x. And then we divide both sides by negative 8, and we get that our x is 2.5. If you don't cancel these x's out here in the beginning like we did, you'll end up with having to factor something out, and it'll be much more difficult than if you canceled it out in the first place. But again, you cannot cancel out the x with the 10 and the x with the 7 because we have that minus 4 on top. For the next one, we want to set up our proportion like this. So we know that something is going to go with 20, and x goes with 10. But we don't know what that something is because we don't know how long this part of our 15 segment is. So what we're going to do is we know that we would take the whole thing and subtract this part to get the other part. But since we don't know what it is, we'll just have to leave it as 15 minus x. So that way when we put them back together, 15 minus x and x would go back together to make 15. So we'll have 15 minus x will go on the top of that fraction, and then we can cross multiply. So our first cross gives us 20x, and then we have 150 minus 10x. Then we'll move our 10x over, so we'll have 30x equals 150. Then we divide both sides by 30, and so we end up with our x equals 5.